Well, hello everybody, and welcome to the Student Revision Tutorials, Unit 1, Mathematical Methods. I'm your panellist this afternoon. My name is Rodney Anderson. I'm a mathematics teacher at Moreton Bay College, and the learning intentions. Now, it's going to be a very, very busy webinar this time round. We're doing a lot of solving equations and calculator applications and solving simultaneous equations, doing it graphically as well, so solving there. Teaching quite a few skills that you may have not seen before, just reinforcing what you know from the class, and solving modelling questions involving functions. So let's get into it. First of all, we had solving the first question, 3p minus 11 is 13. So in the calculator application, we want to solve. So remember, you're using the non-cas calculator. So we press the menu keypad, and I say to my students and other teachers, and we'll work through where would solve be under. So remember, it's a non-cas calculator, so it's numerical solve. So I'm going to go through the algebra menu. Now, I will not use the arrow keypad down. I will not say press 3, I'll say select algebra. So you'll see that I press on the keyboard 3, and we've got numerical solve. So let's select 1. You think, okay, we've got numerical solve here, but what's the syntax? So if I clear the line, I can press the delete keypad, go back, I can press control, clear the whole line. A very important keypads next to each other, the catalog and the templates. So if I just press the catalog, you can see that I've got 6 tabs through here. The most important tabs in my eyes are 1 and 5. 1 listed the commands from A through to Z. So if I just press A, I'm back to the top. If I want to select 5 for the templates, I'll just press 5, or I can use the actual cursor on the screen, the calculator and the handheld. So if I just press 1, now we want to do numerical solve. So you can just press N and then scroll through, but sometimes you think, because it's numerical solve, it's the end of the list of the commands, I might just press O, and if I come back 1, here we are. Now, the important thing about the catalog, it lists the syntax that required when you want to do things, like in here, numerical solve's got the equation, comma, the variable, and you can put in a guess. So remember the syntax, equation, comma, variables. So let's just press enter. Can you see that by doing it this way, you've actually got the end solved there without going to the menu. So we've got 3p minus 11 is equal to 13. Now remember the syntax, we needed a comma, bottom left-hand corner, and then p. And when we press enter, we've got a solution of 8, which is fantastic. Now, you've done the numerical solve, so at times you can actually type it in. Some students wish to type it in, so they know the command is numerical solve. You go N, S, O, L, V. Have you noticed it's like italic? As soon as I press E, it's a recognised command, a stored command. It turns into upright or font, etc. You've got the N solve. Now, you can use that as well. A hidden gem, not a hidden gem, but the situation is that on your calculator, the right click is called the control menu. So can you see the little bottom right-hand corner of that symbols? You got bottom right-hand corner. Now, if I just press control menu, at the moment, this is the right click on that particular application of the calculator. And, okay, you've got something here, not much there. Just wanted to draw your attention to it. So if I just escape this. Now, if you type in the equation 3p minus or subtract 11 is equal to 13, this is the feature I love using in class. If I now press control menu, can you see now I've got math actions? So there's something here, because there's something on the screen, the computer or the calculator said, you want to do something now, let's look at math actions. So select 1, math actions, solve numerically. Now let's have a look. It said solve for P. It's recognised I've used the unknown P. I can type in guesses, etc. But generally, I just press enter, and I've actually got the solution of 8 through there. So I quite like using that. Now, with solving, the second question was x squared minus 4x minus 5 is equal to 0. So if I go to the menu command again, select algebra, and select numerical solve, and we type in the second equation, minus 4x and minus 5 is equal to 0. Now, as you are doing a numerical solve, don't forget what are you solving with respect to? It's x, so we need to do a comma x. Now, let's press enter. Now, as you're aware with quadratics or parabolas, we have two solutions, one solution, or no solutions at all. So let's press enter. We've got one solution. So how could we find the second solution? So we could do restricted domain solutions. So the simplest way to do this, once you've done one solution, use your up arrow key twice and then just press enter. That's the quickest way to actually copy out. You can do Control-C, Control-V, but a lovely feature in the calculator and the computer is actually just use your arrow key or the nav pad up and just press enter and copy it down. We want to say, are there any solutions actually less than -1? So another thing to put in here, we need a restriction. So if I hit the control inequalities template, such that x is less than -1. Now, you might find here that a message comes up and says, there's no solution here, but maybe we should try it the other way. So let's check. We've found the actual lower solution because it gives a little message. Won't go through that just yet. So all we could do is actually do x greater than -1. I'll just press enter. Use the nav pad, the arrow, come back and actually go control inequalities greater than -1 and press enter. We've got our second solution. Now, before I just showed you about using the control menu, which is a right click, what if it just works with our particular polynomial? So we can actually do polynomials. So let's have a look. So we can actually do something in the menu. We select algebra with polynomial tools because our equations are polynomial, and we can find roots of polynomials. So let's just select one and let's have a look. Now, because it's actually a quadratic, we've got exponent 2, reals are okay. What are the coefficients and the constant term? The coefficient was a 1. Now, you can use your down arrow key of your nav pad, or you can actually tab down. I prefer using tab to go from entry field to entry field like a computer. And we have -4, tab down, and we actually have -5, and press OK. So can you see the difference here between numerical solve and the polynomial roots? You can see that we've actually just got the polynomial with respect to x, and when we press enter, we've actually got the two solutions as a set. That's a lovely feature they had through there. Now, what if the actual right-click works with this actual particular one? So let's have a look. So let's type in the actual equation again. As you saw before, if I go control right-click, nothing will come up. It'll have the menu, but it won't have the math action. So if I actually do the same thing before, if I go x squared minus 4x minus 5 is equal to 0. And then if we try, let's see if this works. Control right-click, let's have a look at math action, select number 2. We've also got a thing we can graph it. So we've actually got solved numerically number 2. Escape out of that. You can say math action number 2. We can solve numerically. Now, if I escape out of that one there and say, hey, if I delete this and say x squared minus 4x minus 5, and then I go control menu and select math actions, look what you find here, because you've actually got the polynomial. Beforehand, I had the equation, and the computer or the calculator says, you've got the equation, so therefore numerical solve. So if I want to do the polynomial, type in the polynomial. So when I press enter, and we go, yes, we want to actually find the real solutions, and they've done it for us. That's wonderful. Let's check. There we are. So we've actually got them as well. So with students, some may like the calc application, or some may like the graph application. Now, as you've got a computer in your hands, the Control-I, Control-C, Control-V, Control-X all works. So I personally like using Control-I. Some people use the home keypad or Control add a page. I like going Control-I, and I'm going to add a graph. So we want to do the same thing with x squared minus 4x minus 5. So remember, this first part of the webinar is basically going through our skills we should already know, if not, still learning. So we've actually got our quadratic, and when we graph it, we've actually got the two solutions, haven't we? Now let's do this. There's a few ways of doing this one through here. So with the software I've got in front here, I could actually make the screen a lot bigger and get rid of this row here. But when I press the menu keypad and keep going through, the menus lie on top of each other. What I like doing sometimes in class is actually use this one here, which is the tools. So if I press the menu, it's the same thing as pressing this here. So go menu. I want to analyze the graph. So you think if I need a solution, so I'll analyze the graph, and then I want the zero. So if I was using the menu keypad on the handheld, I press the menu, then I'd select analyze graph, and then I'd select 0. And when I click on the 0, there's a couple of ways of doing this. I'll do one way and do another way that I prefer doing. So because you've actually got the lower bound here, we want to find between the lower bound and upper bound. Use your navpad, which is with your arrows, and I moved across because I've got the computer. I'm actually going to click just before the first solution, and I move my navpad, which is left and right arrows, and click afterwards. I found my first solution. So the first solution is -1, obviously, with the intercept. Now, the method I like using is I know the solutions 1, 2, 3, 4. It looks like about 5, even though we know solution's 5. It's actually, I do the same thing. Analyze graph, 0. It says lower bound. So I know it's 5. So I'm going to press 4 on the keypad. And this little text box comes up. I'm setting the lower bound. So I'm going to say 4, and I'm going to press enter. What's the upper bound? I might say 7. And when I press enter, I've got my solution. There's other ways of solving that on the particular graph, but they're the two that I like. I prefer the second method, just typing or pressing a lower bounds in and upper bounds in and pressing enter, but you do what you feel comfortable for you. Now, in this particular, we've got problem 1. Now we've got problem 1, we've got 2 applications. I'm actually going to open another graph application, so I'm going to go Control-I. And the next one, and the question was, solve 2x squared minus 3 is equal to x plus 3. There's a couple of ways of doing that. Now, because you've got a left-hand side and a right-hand side, that reminds me of simultaneous equations, or we can do it graphically. So what I'm going to do is actually enter the graphs in. Now, because I've already used F1, when I go to the graphs application, now I've actually got another F2. I'm actually going to have 2x squared minus 3. Now, students often say, or they're new to the calculator, when they press enter, the entry line disappears. Now, you could use tab keypad. A little shortcut is Control-G. Control-G, get it back. Control-G, go away. A wonderful educator in Victoria told me and others of this shortcut many, many years ago. It's a wonderful little shortcut, Control-G. So if I just go Control-G, it's come back, hasn't it? I can use up and down arrow keys. Now, beforehand, I could have actually just typed the equation in and then press the down arrow key and the entry line stays there. So my equation is going to be x plus 3. And if I wanted to, and I'll show what happens if I was wanting to enter another equation in, if I use my down arrow key, have you noticed that the equation is plotted and then F4 is ready to go? So I don't want the entry line anymore, so I'm going to press escape. Now, have you noticed that we've actually got 2 points of intersection? So there's going to be 2 solutions here. Now, one method. Let's have a look. So, menu. Which one do you think it would be? Some people say trace, but really we're going to analyze the graph, aren't we? So let's select analyze graph, and we're going to have an intersection, aren't we, which is number 4. So I'll select intersection. Now, like beforehand, I can use my cursor to go left and right, or I can type a lower bound and then upper bound. Just for this one, I'm actually going to use my cursor and mouse, because I'm using the computer, is click left and then click right. There's the first intersection point, or the first solution. And to do the second one, I repeat the same process. I can type in. Now it looks like about 1, 2, maybe I could type in 1. So maybe I can do the same process. I go 1, press enter, and 4, press enter. I've got the second solution, haven't I? Now, I'm going to undo all that and do another way that I find the solutions all at once. You might have a cubic. You might have a cubic that's got 3 solutions being intersected with a line. You might have a trigonometric function. So I'm actually going to go Control Z, or Control Undo. Control Z still works. Now, I'm actually going to show you the pathway. So if you press the menu keypad, Geometry, Points and Lines, and see number 4 there, it says intersection points. So if you're using the handheld, you press the Geometry on the menu keypad, then select Geometry, then Points and Lines, and then intersection point. If you're ever unsure what you have to do, top left-hand corner has the icon. Let's scroll up and have a look, and it says, what have you got to do? Click on the first graph and then click on the second graph. So with your nav pad or mouse, I'm going to come across and click the first graph, second graph, and have you noticed that if I press the escape keypad, I've got both solutions listed at the same time. So that's a wonderful feature to have. So we'll use that through the webinar and through the worksheet. Now remember, there's a worksheet and work solutions that accompany this webinar. They'll be on the TI Australia website soon. Now, as you're doing a tech active exam, it's always best to start a new problem, because I as a teacher would like my students to actually make sure at the end of a tech active exam they've got every question on the calculator, instead of having to retype it and waste time in doing that. So with having a new problem, that's the best way about doing it. So that we've just done question 1. So let's do question 2. So insert a new problem. Press the document keypad, select insert, and select a new problem. I'm going to add a calculator application. Can you see that problem 1 had 3 applications? And problem 2's got its first application here, which is the calculator application. Now, beforehand, I defined equations. So if I press the variable keypad here now, have you noticed there's no variables defined in here? If I just escape out of that and go back to a few and go back to the calculator, and when I press the variable keypad, can you see all the defined variables that are listed there that have got 3 functions defined? So if I go back to problem 2, I'll just take it nice and slow. I can use my cursor to go to the top of the screen and click on it, but I'm navigating control right, control left. Now this one says solve the following simultaneous equations. So I'm going to do it in a calculator application now to start with. So menu, algebra. Now where would it be here? The 2 functions were linear, weren't there? So solve system of linear equations. So number 2, I'm going to select solve system of linear equations. We've got 2 equations and both the variables are x and y. Yes, happy days. So what were the 2 equations? The y equals 7x plus 8. You can use your arrow key of your nav pad to come down, or you can just press the tab keypad. And the second one was 12x minus 2. So we're solving simultaneous equations with respect to x and y, and we press enter. We have got 2 and 22. So 7x plus 8 and 12x minus 2. Now, a lot of students prefer doing this with the graphical approach. So we can actually do this in the graphing approach. We can actually use a graph application and graph the 2 equations, do the point of intersection. But we've got a lot to get through with this webinar, and we'll keep on going. So that was just the first question, just as a reminder. Now, question 2 is done, so let's go to question 3. You know what we're going to do now, don't you? So correct, document, insert, a new problem. Here's our new problem. Now, this one's a worded problem. It actually is with simultaneous equations. It says entry tickets for local show cost $32 for adults and $14 for children. A group of 13 people pays $254 altogether. So do a bit of working to decide, show some working. So we want to solve these simultaneous equations. So first one, we need to actually do menu, algebra, system of linear equations, number 2. Now be careful here, depends how you define your unknown, because we've got adults, I'm going to say A for adults and C for children. So if I just press tab, I'm going to come down and call this A and C for children. So can you see straight away we've got the linear solve, we've got the equation. So what have we got? We know that the number of people attending is 13. Let's check. So we've got a number of adults, a number of children is 13. And refer back to the question all the time. And what's the total cost? We have $32 for adults. And we had $14 for children. And it's equal to $254. So we've got our variables or unknowns as A and C, and we press enter. We have 4 adults and 9 children. Now, if you wanted to do this graphically, insert a graphs application. Now, with your entry line is function notation. I like using relation notation, so I'm actually going to show you the pathway. So if you did press the menu keypad, you've actually got the graph entry, and you're actually going to select relation straight away then. Okay, so escape out of that. So we go menu, graph entry, and change it to relation. Now, it's got relation X and Y, so let's go back to what we had before. We're going to have X plus Y is equal to 13. Use my down arrow key or the nav pad. See, it's actually kept my entry line there. And the second equation is going to be 32 X plus 14 Y is equal to 254. And then press enter. Uh-oh, it's off the screen. Now, just remember with the handheld, a couple options of actually doing to look at this and look at the solutions. So one method is actually to go into menu, window, and some students and teachers will do things differently, like to actually fit and so forth, but I always like to go into window settings and change the window settings to suit me. You're making control, whereas the computer and software is thinking about what would you like to see and do. Another lovely feature is if you have your particular cursor out here in anywhere in the actual area of the Cartesian plane and hold the center of the nav pad down for 2 seconds, we'll go control and click, you'll actually grab. Now it's easy on the computer. When I do that, I can actually grab and see what happens. I can move my screen around at any time and think, oh, there's a point of intersection. Now, like before, what could I do? I could actually go into menu. 2 options. I can go into analyze graph. I can do intersection. Or, let's escape out of that. So imagine you're doing it again. I could go into geometry, points and lines, and then I can go intersection points. And like beforehand, if you're not sure, lay your cursor over the icon and shows you what you've got to do. So if I click the first relation and then the second relation, we've actually got our point of intersection. So to get out any setting you're in here, just press the escape keypad. So we've actually got a solution to simultaneous equations graphically and then using the calculate application. Now, question 4. Well, question 4, so what have we got to do? Document keypad, insert a new problem. So it says determine the minimum and maximum values of the function g of x is x squared minus 5x plus 1 from -4 to -7. So we can look at it in the calculate application, but I'm going to actually add a graph. So let's add a graph. And we need to type in x squared, subtract 5x, and add 1. Now, before I just press enter, remember we're going to have restricted domain. So if I look at the graph, I need to actually add a restricted domain. So the simplest way of doing it is actually going control in the inequality menu And one of the most important symbols is such that given, or I call it such that, or given. And we need to put in the restricted domain. So it's actually going to be -4, control, inequality, X, control, inequalities, and what was it? 7, wasn't it? So x squared minus 5x plus 1, double check, always check this for the exam, and then we press enter. Yeah, oh, that's not very exciting, looks like the straight parabola, but don't forget, it's off the screen. Now you can actually use your, as I said before, move the cursor around and move it into a particular Cartesian plane quadrant, click for 2 seconds, grab it. We can actually change the window. We can actually try fit, but let's try to change the window. So let's go to the menu, window, zoom. Now, like I said, some people like to do a whole lot of things, but I'm actually going to change my window settings. So I actually like to say, hey, let's have a look. Let's see what we do. Window settings. Now, we know we're going from -4 to 7. So let's go from -3, tab down to 8. I like going 1 below or 2 below and 2 above. And tab down, let's say the scale is 1. The Y minimum, what could we do? We could actually try a few things. So you look at the function, you know the turning point's going to be something. So -2.5, we look at that there. So we can actually just try. Let's try a few things. Let's go, say, -4. And the Y value, let's suppose we go to, say, 40. And we're going to have a scale, tab down, let's have a look. Let's say make it 5. Let's see how we go. Oh, we're nearly there. So we got it right up here. Maybe -3 is actually not good with that one there. So we've actually can look at that. So we'll actually have a look. So we go to the window settings, and the X minimum. We looked at -3. We've got the restrictions, so we need to tab down. This is what you can do and fit. So maybe you can look at the Y minimum. Let's go back up to here. Let's go -10. Let's see if that works. Yeah, we've got it. And let's double check Control G. We'll actually check our function. Let's have a look. We're going x squared minus 5x plus 1, -4 up to 7. Now, with this situation here, you can see that we've actually got our restricted domain graphing, and it's going from -3. Is it correct on the screen? So we wanted to go from -4. So let's double check. So we go back to our window, and we say -5. So it's a bit mucking around here, but it's how confident you're going to get with your particular calculator. Let's have a look. There we are. We've got our restricted domain. So we look at this one here and say, hey, we've got our restricted domain. Another thing we'll do here shortly is the table value. We can see that situation. So at the moment, we've actually contested the endpoints of our graph, and we can see that there's going to be a minimum. So it's going to be a local minimum. So menu, let's trace. Now in through here, you can see this graph trace. You can trace a particular graph or coordinates, or you can trace all. If you've got 3 or 4 functions or relations on the screen, you can graph and check the coordinates. So let's select graph trace. So let's type in -4. Let's check the end boundary. -4. So its maximum value is 37. Looking through here, I think 37 would be our maximum value. Let's test the actual right-hand end. So we're still in that setting here. So we just type in, say, 7 now. You see there's another text box nearby around the screen. And when we press enter, it is 15. So it's not going to be the local minimum. So the local minimum is down here, isn't it? So let's press escape. And we need to analyze this. Let's have a look. So we need to analyze it. So we select number 6, analyze graph, and we select minimum. Like beforehand, we can actually use our navpad cursor or type values in. If I click before and click afterwards, and you've actually got 2.5, -5.25. Just be careful here. Sometimes you'll see that here I've got 3 significant figures. If I go through the actual menu icon, and you'll see settings, settings, When you click into here, sometimes you'll see display digits only 3. You might find that you might need to change that to 4, 5, or 6. So that's 3 significant figures. So escape out of that, and you'll see that. Now, like in some webinars beforehand, a useful feature is a table of values. So if I actually go Control T, can you see here when the X value is a whole number or integers, we can actually go and see what they are. So you've got to be very careful here. You could change it to go up in increments of 0.2s or 0.5s. That's a good useful feature to see. So you can actually go through here and check values. So we go to 7. We can go back down to through the negative values of X. You saw it was negative 437. So let's just hide that table again by Control T. So you've actually found the maximum and the minimum of a particular function and testing the endpoint. Now we've got 2 questions to go. We've covered a lot here now. So we're in question 4, and you think, okay, got a short amount of time, so we need to look at actually going very quick in the exam. So you think, remember, this could be you in the exam. You think, oh, wish I hadn't deleted. Well, you haven't, because you're inserting new problems every time. So let's insert a new problem. Now, this problem was the parabola of ax squared plus bx plus c passes through 3 points. We determine the values of a, b, and c. So I'm going to add a calculator application, and I'm going to define a function. So I'm actually going to define the function of f of x, and I'm going to go Control Define. There's a few ways of doing that. Some people, as I said before, go Control Store. Some people actually use the word define, type the word define in, but I find it's easiest Control and define. Now, it's ax squared. Now, be very careful here. It's a multiplied by x squared plus b multiplied by x and add c. You think we've got 3 unknowns here, so maybe simultaneous equations will come in handy here. So we've actually defined the parabola. Press enter. And we know that passes through the points negative 215, 2, 3, and 310. So what could we use? Let's press menu. Obviously select algebra, and what are we going to use? Now remember, it's this solved system of linear equations. Even though it's parabola, when we actually put in the values of x as substitution, there will be a linear equation in terms of the variables a, b, and c. So select number 2, which is solved system of linear equations. And we're going to have 3, tab down. Now be very careful, it's not x, y, and z, it's going to be a, b, and c, isn't it? And we select OK. So we've got our template done for us. Fantastic. But because we defined the function, we can actually use the variable keypad. And I'm going to say the f of negative 2 is equal to 15. Tab down. F of 2 is 3. Now, if you didn't do that, you'd like prefer doing it this way, press F. It's bold because it's defined. And 2 is equal to 3. And tab down, or just go back to the variable keypad. And we've got 3, and it's equal to 10 as the y coordinate. And when we press enter, there we have it. So it's going to be 2x squared minus 3x plus 1. So we've done question 5. Ready to finish the exam. We've got 1 question to go. So we can go through and check a few things in algebra here. We talk about numerical solve. We've done that and looked at all that. So we've got to insert another problem. So insert problem. We're up to question 6 now. Now question 6 was a simple optimization question, but it's actually looking at maximums and minimums. So a traditional type of question is construct a rectangular enclosure with a maximum area using 20 metres of fencing wire. Now I picked a very simple one because most of the time with those questions it could be a square. Sometimes slant on this question you've been given it to a fixed fence. So you might have a fence on your property and you're creating 3 sides to the particular rectangle. But for this one here, I'm actually going to add a graphs application. And you've done a bit of work beforehand. So you've actually worked out the optimal equation. So you're actually going to have x multiplied by, I'm going to have it putting the multiplication in all the time. I should do that. And it's going to be 10 minus x. Now, with this one here, you think, okay, the first solution should be a 0, and the first one should be a 10. So you're going to see something here, and it's going to just drop over here, but we need to find if it's a maximum area. So let's just press enter. Okay, now, this doesn't make sense, does it? Because we're going to have negative dimension. Obviously, if we come over here, if I just grab this and move it here, you can see negative dimension. That's not good, is it? So if I just undo that. Now, some people like to actually use a window. I prefer using a window with the actual settings, but some people like to press the menu, the window zoom, number 4, and they like to do zoom fit. So let's try and see what the computer does for us, the handheld does for us. So we select A. That's okay. We've got a rough idea. It should go between 0 and 10. We don't need, looks like it goes up to 50, for example, maybe 40. So we've got a rough idea that we can actually check our own solutions. So then I like to actually go through a menu, window settings, and I know it's actually say -3, for example, and we tab down. I might make that to a 12. I might scale the go up and say 2s, maybe -20, or not -20, possibly -10. Tab down, and we said it was 47, so let's make it say 40. Tab, the scale of 5, and when I press enter, I like seeing that the axes in the actual windows. At times you might see axes right on the edge of the screen. I personally like to see the axes in the window. So the question was determine the dimensions of the maximum. So it's the local maximum, here it is here. So we're going to analyze this graph. Select analyze graph, and we have maximum. Now, like beforehand, you can type in lower bound, or you can actually use your nav pad and press enter just before and just afterwards. So it says when x is 5, the maximum area is 25 square meters, so that makes sense. So therefore x is 5, y is going to be 5 as well. So it's actually going to be a square, so 4 lots of 5 is 20. So with our particular webinar, we've actually seen a lot of defining functions, evaluating, then we've actually looked at solving. There's a few ways of doing that. You make sure you know what you have to do, and as I said before, you've just finished your exam, you've got 6 questions, and then, oh, I've got 5 minutes to check, so let me go back and check question 5. Yeah, I've done that right. Go back to question 4, that looks pretty good, I can look at it. So you're not panicking towards the end of a tech active exam, so you're looking at that with the problems. So hope you've enjoyed that webinar, and as I said at the start of the webinar, there'll be a worksheet and work solutions accompanying this online recording on the Texas Instruments Australia website. Until next time, take care.